Here is a very beautiful question based on related rate of change. We are going to analyze cross section of a trough which is a right angle triangle. The question here is a cross section of a trough is an isosceles right triangle, the base of the triangle being horizontal and uppermost. The trough is 10 meters long. Water is poured into the empty trough at a constant rate of 5 meter cube per second. Find the rate at which water level is rising after 9 seconds. Let us first sketch the diagram. So we have a right triangular isosceles trough whose length is given to us as 10 meters, right? So, and the water is being filled into it. So let's say this is the water being filled. So let us assume that the height is h. This is 10 meters. So dv dt, the rate at which water is being filled, is 5 meter cube per second. We are interested in finding the rate of change of height at 9 seconds. So we need to find what is dh dt at t equals to 9. So first thing is that we have to relate the volume in terms of height. How do we do that? Now, as some of you might know, that in a right angle triangle, if I drop from any vertex perpendicular to the hypotenuse, all the sides are equal in isosceles right angle triangle. Since see, this is 45 degrees, correct? So the two sides h and h will be equal. So basically, the base of this triangle is 2h and height is h. So area of triangle is what? So area of this triangle is basically equal to half base is 2h times h. Means h square is the area of the triangle. So we can now write down the volume expression which will be area into length. So h square into 10 meters, right? So or 10h square. So that becomes the volume of this particular trough. Now in 9 seconds, what is the situation? How much water will be filled? Since the rate of filling the water is 5 meter cube per second, we know that the volume at t equals to 9 will be 5 into 9, right? Which is 45 meter cube. So that is the total volume. Now, if that is the total volume, then for this volume, what is going to be the height? You see that? That is how everything is connected. So let's find the height. We know that the volume is 45 and 10h square. So 45 divided by 10 square root will be the height. Correct. Or you can say square root of 4.5. So this is the height at t equals to 9 seconds. Is that clear to you? Okay, perfect. Now what do we need to find? We need to find the rate of change of height after 9 seconds, correct? We have all the parameters with us. So what we can do is that we have the volume expression which is 10h squared. So let's do it here. Or on a fresh page we can do. Okay, so we have volume expression as 10h squared. We can differentiate with respect to time, correct? So that means we get dv dt equals to 20 h dh dt. So we can find what is dh dt now, right? So dh dt will be equal to 1 over 20h times dv dt. Perfect. We already calculated the value, so now we can find dh dt at t equals to 9 as 1 over 20. H value was square root of 4.5, right? And dv dt is given to us as 5. So let's use the calculator to find this value. It comes out to be square root 2 over 12. So height is in meters per second. So that is how we are going to solve this question. You get the idea. So when we are talking about application questions on related rates, there are so many parameters to be connected. As in this particular case, we first found the area of a right angle triangle as half times 2h times h square. Volume times 10 because the trough was 10 meter long, and then the derivative. And we also found after 9 seconds what will be the height, and then the rate of change of height at t equals to 9 seconds. So I hope all the steps are absolutely clear to you. You may go through this video once again and check many more videos from our playlist. That should help. Thanks for your valuable time and all the best.